7.4 Inverse trigonometric functions. When a function is one-to-one, that means that it has an inverse, and we know the inverse is signaled by the -1. And back a couple chapters ago, we would switch where x and y is and solve for y. But now we're going to be working with trig functions. So on the coordinate plane, we have our sine function with a max height of 1, minimum at -1. The inverse sine takes the area from -pi/2 to pi/2 and flips it. So we're taking this little area right in here and we flip it. So it still goes through 0, 0, but it goes on the x to 1 to -1, and on the y, pi/2 to -pi/2. So this is the graph of the inverse sine. The inverse sine function is the function inverse sine with domain -1 to 1 and range -pi/2 to pi/2, and is defined by inverse sine of x equals y, therefore sine of y equals x. It's also called the arc sine, which we have used in previous lessons. Here are some general properties. Sine and inverse sine undo each other, so you get out x. And these are our domains. So for sine inverse sine of 1/2 for part A, we have to remember that it's on the interval -pi/2 to pi/2. So we go to our unit circle and we look for a sine value from pi/2, -pi/2 to pi/2. That is 1/2. So here's pi/2. -pi/2 would be at the 270-degree mark, and we're looking for a sine value that is 1/2. And we see it right here, and it occurs at pi/6. So our answer is pi/6. So now, for sine inverse sine of -1/2, we know from our earlier properties with negatives, we can take the negative and move it to the front. Negative sine inverse of 1/2. And we know that the inverse sine of 1/2 is pi/6 from the previous problem. Bring down the negative, and it is -pi/6. For C, inverse sine of 3/2. 3/2 is greater than 1. This is not in our domain. Therefore, it is undefined. find approximate values for A, sine, inverse sine of negative 8.2. Because it's saying approximate values, that means we can plug it into the calculator. And please make sure your calculator is in radians, not degrees. So you plug it in and we approximate it. Let's take it out to 3 decimal places. You get 0.961. Part B, arc sine of 1/3. And we'll have to approximate it using our calculators, and we get 0.340. Finding cosine of arc sine of 3/5. Okay, so we're working with sine, cosine, and theta. So we're going to set this up into a right triangle. So here's our right triangle. And we just need to label one of them theta for our angle. Here's theta. Sine inverse is of 3/5. So that means we are working with 3/5 for sine. And so 3 would be opposite, and the 5 would be the hypotenuse. So let's go ahead and fill those in. Got 3, 5, and we have to use the Pythagorean theorem to find the third side. But I know this is a 3, 4, 5 triangle, so I fill it in. So we're going to replace this inverse sine of 3/5 with theta. Because that is how we set up our right triangle. So now we want the cosine of theta, and remember cosine is adjacent over a hypotenuse, so we just go 4/5. If you wanted the tangent, this is just an extra one, tangent of arc sine of 3/5. We would just replace that with tangent theta, and we would get 3/4. Inverse cosine function. So we have a sketch of y equals cosine. So we're going to take from 0 to pi on the x and from -1 to 1 on the y, and we're going to flip it. So our inverse cosine is going to go from -1 to 1 on your x and from 0 to pi on your y. So we're going to start at 1, 0 because we started at 0, 1. I'm going to go up. Oh, that was kind of bad. There we go. And this is the graph of inverse cosine. It has domain -1 to 1 and range 0 to pi. Also called arc cosine, which we have used before. And cosine and inverse cosine cancel each other out, and you get just x. We're going to find the inverse cosine of √3/2. And we need to remember its interval is from 0 to pi, which is the upper half of the unit circle. Cosine is your x value, so you want your x value to be root 3 over 2, which occurs at pi over 6. Part B, cosine, inverse cosine of 0. So we want our x value, so on the interval of 0 to pi, to be 0, and we know that occurs at pi over 2. And C, inverse cosine of 5 over 7. Now 5 over 7 is not a part of a terminal point on the unit circle. So when it's not on the unit circle, we must use a calculator and approximate it. So it's approximately 0.775. We're going to write sine of inverse cosine x and tangent of inverse cosine x as an algebraic expression for x being in -1 to 1. So we're working with sine of our cosine and tangent of our cosine. So both of them are taking it of the arc cosine. So we're going to set theta equal to the inverse cosine. So if we wanted to solve for x, normally it would be the other way around. So now we're going to be taking cosine of theta equals x. And because we'll be setting up a right triangle, that will be over 1 for adjacent over hypotenuse. So let's set up our right triangle. So we have theta as one of our angles. We have x. Nope, that's not x. This is x as your adjacent, and your hypotenuse is 1. So let's use the Pythagorean theorem. X squared plus b squared equals 1 squared. B squared equals 1 minus x squared. So b equals root 1 minus x squared. Now we have our third side of our right triangle. So now we can use this to identify the sine and cosine. So I have sine instead of inverse cosine x. It is now theta. And using our right triangle, we go opposite over hypotenuse. So that is root 1 minus x squared over 1. So therefore it is just root 1 minus x squared. Let's move on to tangent. Now we're looking at tangent theta, and tangent is opposite over adjacent. So opposite is root 1 minus x squared. Adjacent is x. We cannot simplify anything, don't need to rationalize anything. So our tangent of inverse cosine of x is root 1 minus x squared over x. Write sine of 2 arc cosine x as an algebraic expression in x, where -1 is less than or equal to x, which is less than or equal to 1. So now this is saying we need to get rid of sine and cosine. We don't want any trigonometric functions in our answers, just in terms of x. So we have sine of 2 cosine, inverse cosine of x. So once again, we're going to take theta and set that equal to inverse cosine of x. Therefore, cosine of theta equals x. So this is just like the last problem. We're going to set up our right triangle. We have theta. We have adjacent is x, hypotenuse is 1, and we already know the opposite is 1 minus square root of 1 minus x squared. So we're going to replace the inverse cosine of x with theta. So now we're at sine of 2 theta. And from our previous lesson, we can use our double angle formula. And change this to 2 sine theta cosine theta. So now we're in sine theta and cosine theta, which we can use our right triangle to find these. So sine theta opposite over hypotenuse. So root 1 minus x squared over 1. So we're going to plug in root 1 minus x squared for sine theta. Cosine theta becomes x over 1 for adjacent over hypotenuse. So we're known as times by x. So we have 2 root 1 minus x squared times x. The only thing that we can rearrange is the 2 and the x at the front. So we get 2x root 1 minus x squared. There's nothing more we can do. We are in terms of x. That is our answer. So for the inverse tangent function, we take the tangent graph, which has asymptotes at pi over 2 and negative pi over 2, and we flip it. So now we have asymptotes where y equals pi over 2 and y equals negative pi over 2. And the graph is going the opposite way. So now this makes our domain all real numbers. And our range is from negative pi over 2 to pi over 2. And notice the parentheses because it is not included. So the inverse tangent function is also called the arctangent. Thus, the inverse tangent is a number in the interval negative pi over 2 to pi over 2 whose tangent is x. So, and we know tangent and tangent inverse are inverses, and therefore you get out just x. So we are going to find the inverse tangent of 1, and our interval is restricted to negative pi over 2, pi over 2. So we want a tangent value of 1. So that means that sine and cosine must be the same thing. So that occurs where it is root 2 over 2, root 2 over 2. And the radian value is pi over 4. For part B, we have the inverse tangent of pi over 3. So that means sine divided by cosine had to become root 3. I'm sorry, that was supposed to be root 3. Okay, so that means we need a root 3 somewhere in there. And we know its denominator is 2, because it always is. And we also need a 1/2. Now we just need to know the order, which will need to go in the numerator. The root 3 over 2 does. because you will end up multiplying by the reciprocal, getting root 3 over 1. So our terminal point is 1/2 root 3 over 2, which occurs at pi over 3. Part C, tangent of -1, inverse tangent of -20. You're not have to use a calculator, and we approximate it to -1.521. Now there are inverses of secant, cosecant, and cotangent. Secant is the reciprocal of 1 over cosine. So inverse secant is the inverse cosine of 1 over x. Cosecant is a reciprocal of sine. So inverse cosecant is inverse sine of 1 over x. Inverse cotangent is the inverse tangent of 1 over x.